Hello, and welcome to Module 4.2b, Rate of Change and Slope. Today's objective is that I can calculate and interpret slope. So what is slope? Slope is the rate of change in the y-coordinates, the rise, for a corresponding change in the x-coordinates, the run, for points on the line. So there are a couple different ways that we can represent slope. Slope can be the change in y over the change in x. It can be y2 minus y1 over x2 minus x1. Keys to pay attention to here, I need my highlight tool, we are going to have one pair of coordinates first and a second pair of coordinates second. Another way you may hear of slope being referenced is the rise over the run. And you could also see it as delta y over delta x. That is the Greek letter delta, the triangle, and it means the change in. Now, when we're looking at a graph, we are looking for the rise, how much we are going up. That's going to be our y2 minus y1, versus our run, which is how much we're going to the right, and that's our x2 minus x1. And we can see how those points are laid out in the two ordered pairs that are provided that we're looking at here. So let's go and let's look at finding slope using a graph. And we are given 2 points on the graph, one of them right here and one of them right here. So when we have a graph, we can find our slope by counting. So we're going 1, 2 hops up, and we're going 1, 2, 3, 4, 5 hops to the right. So our rise is 2, our run is 5. Leave slopes as a fraction, as it is much easier to represent them on a graph if they are a fraction. Letter B. We have our points here and here. And so we can count. We are going to go down 1, 2. So that's negative 2 because we're going down. And then we're going to go to the right 1, 2, 3, 4, 5, 6. So we have negative 2 over 6. And we always reduce our fractions, and we're going to leave it as a fraction, and it's going to be negative 1/3. Letter C, where you need to find some points to use on this one. So I'm going to use this point right here and this point right here. You're looking for places where you are evenly and nicely hitting the corner of one of your grid lines, so you're not estimating as to what the value is. So we're going to increase by 1, and we're going to the right 1, 2, 3, 4. And it may seem juvenile that I'm drawing in these hops every time, but you'd be surprised how many times you think you count the right number of grid lines, but you don't. So if you draw the hops in, you know you're hitting all of the grid lines and not missing any, and also not adding any that don't exist. Letter D, again, we need to find 2 coordinates, and so I'm going to use this one, and I'm going to use this one. And so we're going down 1, and we're going to the right 2. So it's negative 1/2. Now, if I pick this point right here and I follow my pattern, down 1 and right 2, I'm at another point on the line. Down 1 and right 2, I'm at another point on the line. But I can also work my pattern backwards. I can go to the left 2 and up 1, left 2 and up 1. And you'll see we're still making the same relationship happen, whether we go to the right or we go to the left. We just need to remember that if we're going to work our way backwards on the line, we need to flip our operations around, and we're going to go up instead of down and left instead of right. All right, there are 2 U-Try problems at the bottom of the page that I would like you to do on your own, and then come and check your work against mine. Letter E, we have our points identified for us, and we're going up 1, 2, 3, 4. And we're going to go 1, 2, 3, 4, 5, 6 to the right. So 4 over 6 is going to reduce to 2 over 3. Letter F. We're going down, so it's going to be a negative 1, 2, 3, 4, 5, 6. We're going to go to the right 1, 2, 3, 4. And so negative 6 over 4, that is going to reduce to negative 3 over 2. All right, so now we're going to go to the next page, and we are going to calculate finding slope using 2 points. And this is where we're going to use that x2 minus x1 that I talked about before. So we have x1, y1, let me use green, x2, and y2. So our formula was y2 minus y1 over x2 minus x1. So let's substitute in our values. Y2 is 1 minus y1 is 3. X2 is 4 minus x1, which is 1. So we do 1 minus 3 is negative 2. 4 minus 1 is 3. And that's our answer. We don't need to simplify because there's nothing to simplify. Letter B. What is the slope of the line through 4, 3 and 9, 2? So let's identify our points. x1, y1, x2, y2. And if we go ahead and do the subtraction, we do 2 minus 3 over, we have 9 minus 4. 2 minus 3 is negative 1 over 9 minus 4 is 5. All right. And that's our final answer for the slope. Letter C, what is the slope of the line through the points negative 3, 2 and 1, 5? So we label our x1 and y1, x1, y1, x2, y2, and we do our subtraction. So 5 minus 2 over 1 minus negative 3. 5 minus 2 is going to give us 3. 1 minus negative 3 is 4. And so our slope is 3/4. Letter D. What is the slope of the line through these points? So again, x1, y1, x2, y2. So we're going to do 7 minus negative 9 over, sorry, not 7, negative 4 minus negative 9 over 7 minus negative 3. And 4 minus negative 9, 4 plus negative 4 plus 9 gives me 5. 7 minus negative 3, 7 plus 3 is 10, which reduces to 1/2. Now, let's do a little alternate universe here. And let's say I flipped those around and I did y1 minus y2. So if I did negative 9 minus negative 4 over negative 3 minus 7, what am I going to get? I'm going to get negative 9 minus negative 4 is going to give me a negative 5. And that's going to be over negative 3 minus 7, negative 10. And that's going to reduce to a positive 1/2. So no matter which ordered pair you identify as x1, y1 or xy, x2, y2, you're still going to get the same exact value for your slope as long as you do your subtraction correctly. So it doesn't matter which one you identify as being x1 and y1. All right, there are 4 U-Try problems for you, and I want you to do those on your own now. All right, letter E. We're going to do 2 minus 6 over 3 minus 1. That gives me negative 4 over 2, and that's going to reduce to negative 2 over 1. Now, you can write it as negative 2 over 1. You can simplify it and just say that it's negative 2. Either way, it would be acceptable. writing it this way does give you that little bit of a verbal cue or visual cue that you have a denominator of 1. So when you're going down 2, you're going to move to the right 1 in terms of graphing. It just gives you a little visual representation for it. Letter F, we're going to find the slope, and so we need to do y2, 6, minus y1, 2, over x2, 9, minus x1, 8, and 6 minus 2 is 4, and 9 minus 8 is 1. And so there's our slope. Our slope is 4. Letter H, we'll just work our way down the page here. We're going to do y2, negative 4, minus y1, 7, over x2, 2, minus x1, 5. And when I do that math, negative 4 minus 7 is negative 11, over 2 minus 5 is negative 3. And a negative divided by a negative becomes positive, and so we have our positive 11/3 as the slope. Letter H, what is the slope of the line through 3, 1 and negative 3, 5? Again, we're going to do y2, 5, minus y1, 1, over x2, negative 3, minus x1, 3. 5 minus 1 is 4. Negative 3 minus 3 is negative 6. And that simplifies to negative 2 over 3. Now, example 7 and 8 is finding slope of horizontal and vertical lines. So letter A, we have a line here that's horizontal. And I'm going to just pick 2 points. I'm going to pick that point. I'm going to pick that point. So negative 1, 2, 3, 4. Negative 4, and we are up 1, 2, 3, 4, 5, 6. So we have negative 4, 6, and we have 1, 2, 3, 4, 5. So we have 5, 6. And if we want to find the slope, it's the rise over the run. So we do 6 minus 6, y2 minus y1, over x2, 5, minus x1, negative 4. We end up with 0 over 9. And 0 divided by anything is 0. That is your final answer. This is what I am expecting you to write. If you write 0 over 9, it is not correct. I need to know that you know that 0 divided by 9 will give me 0. And we can see this also. Our run, 1, 2, 3, 4, 5, 6, 7, 8, 9. There is no rise because there's no up or down, so it's 0 and 9, 0 divided by 9. Letter B. If we pick 3 points, I'm going to pick this one right here. That's 3, 0. And let's go up to here, and that's 3, 5. Now, if I do this one, y2 minus y1, so we have 5 minus 0 over 3 minus 3. I'm going to get 5 over 0, which means it is undefined. And I didn't give myself enough room. You must write that it is undefined. If you write 5 over 0, it will be marked wrong, because I need to know that you know that anything divided by 0 will be an undefined slope. Because again, we're going up 1, 2, 3, 4, 5. So our rise is 5, but our run is 0. So it's 5 over 0, which is undefined. All right, I'm going to ask you to do letters C and D on your own. These are finding slopes of horizontal and vertical lines, but they are using ordered pairs instead. All right, so now we're going to check our work against mine. 6 minus 23, y2 minus y1, over 10 minus 10. And we're going to get 6 minus 23 is negative 17 over 0. So this is undefined. And that's your final answer there. Now, letter D, we have the points 3, 8, and 6, 8. So we have y2 minus y1, 8 minus 8, is equal to x2, 6, minus x1, 3. And so I'm getting 0 over 3, which gives me a slope of 0. Now, example 9 is an interesting little twist on working with slope, and it's finding the coordinate given the slope. So let's say we know the slope. We need to find what is the missing coordinate of an ordered pair in order to create a line with that slope. So letter A, find the value of r so that the line passing through -4, 5, and 4r has a slope of 3/4. Well, let's go back to labeling. So we have x1, y1, x2, y2. And now we're going to go ahead and use our formulas. So y2, r, minus y1, 5, over x2, 4, minus x1, -4. And that's going to be equal to our slope, which is 3/4. So now we need to cross multiply in order to solve this. So, well, first let's do our simplification. 4 minus -4. So we have r minus 5 over 4 minus -4 is 8 equals 3/4. Now we're going to cross multiply. Nope, we're not going to cross multiply. We don't need to cross multiply. We just need to multiply both sides by 8. I'm getting ahead of myself on the problems. Multiply by 8. We get r minus 5 is equal to 8 times 3 is 24, divided by 4 is 6. And now my final step is going to be to add 5 to both sides of my equation. And I get that r is going to be equal to 11. And we can go back and we can check our work. 11 minus 5 is going to be 6, divided by 8 is going to be reduced to 3/4. Now, letter B, we want to find the value of r so that the line passing through -3r and 7, -6 has a slope of 2 2/5. Well, let's just take that immediately. And 2 2/5, let's make that an improper fraction. It's going to be 12/5. So now we need to set up our subtraction. -6 minus r over 7 minus -3 is equal to 12/5. We'll rewrite that a little better. Equals 12/5. My first step is going to be to do the subtraction in the denominator. So I have -6 minus r over 10 is equal to 12/5. Now we multiply both sides by 10. And we get -6 minus r is equal to 120 divided by 5 is going to give me 24. I'm going to add 6 to both sides. And I get -r is equal to 30. And I divide by -1, and r is going to be equal to -30. And we can substitute that back in. -6 minus -30 will give me 24, and I'm going to divide that by 10. 24 over 10 reduces to 12/5. All right, there are now 4 you-try problems for you to give a shot on. You're going to go ahead and do those on your own, and then check your work against mine. Example C, we have a slope of -1/2, so we're going to set up our subtraction. 8 minus 4 over r minus 2 is equal to, we're going to go -1/2. This one we're going to want to cross multiply for. So we have 8 minus 4 in my numerator, which is going to be 4, and we're going to multiply that by 2, which is 8, and that's going to be equal to, we're actually going to say that's going to be my negative 8. We're going to keep the negative sign down below here. And now we've got r minus 2 times 1, so that's r minus 2. Okay. And now we need to just add 2 to both sides, and we get negative 6 is equal to r. Letter D, we have a slope of negative 5 halves. So we have 9 minus r over 1 minus 3 is equal to, and we're going to put negative 5 over 2 to just assign it to one part of the equation. So let's do our subtraction in our denominator first. So we have 9 minus r over negative 2 is equal to negative 5 over 2. And we are going to multiply both sides of our equation by negative 2. And we get 9 minus r on the left. And negative times negative, so that cancels out. 5 times 2 divided by 2 is going to be 5. We subtract 9 from both sides, and we get negative r is equal to negative 4. And we divide by negative 1, and r is going to be equal to positive 4. So the work got a little smushed in there, but the point gets across. Now letters E and F are a little more challenging, because in letter E, I'm telling you that you have an undefined slope. So what does that mean? Well, let's set up the left side first. So we have 2 minus 5 over r minus 3 is going to be equal to, if it's undefined, I know my denominator has to be 0, and I can put anything in my numerator because anything divided by 0 is undefined. So I'm going to just keep it simple and use a 1. So now let's cross multiply. Anything times 0 is 0, and r minus 3 times 1 is r minus 3. And now all I have to do is add 3 to both sides. And I get 3 is equal to r. Now, my students in class earlier today, they pointed out the fact that all we need to do is get that denominator to equal 0, and we will have our value for r. And we just set r minus 3 equals 0, and you find that r is equal to 3. Either approach is going to get you to the same answer. All right, letter F. We are now finding a slope for a line that has, or finding a point for a slope of 0. So I set up my left side, r minus 3 over 2 minus negative 3. And if it's going to be a slope of 0, I know I have 0 in my numerator. And let's just keep it simple again and do over 1. So r minus 3 is going to be equal to 0, and then we're going to add 3 to both sides, and we're going to get r is equal to 3. Again, I'm just looking at that top part here. In order for it to be 0, the piece on the left, r minus 3, needs to equal 0. So now we're going to move on to problem number 10, or example number 10, which is using slope. So we want to know what is the slope of the continental slope at Cape Hatteras, and you go from the continental shelf to the oceanic crust, and this boundary layer is the continental slope. So we have our coordinates right here. So we have x1 and y1, and we have x2 and y2. And now we just need to find the slope of those. So we have negative 2700 minus our x1 is negative 65 over 125 minus, oh, the 5 disappeared, 125 minus 75 from the shore. And when we do that subtraction, we're going to get negative 2635 over 50. And do that division, we're going to get negative 52 32.7 meters per meter. And this one's just a little weird that both of our units are being measured by the same measuring system. So it's a little kind of wonky, but it's meters deep over meters away from the shore. So for every meter you leave from the shore past the end of the continental shelf, you're going to drop 52.7 meters below the surface. All right, letter B. On a flight from Chicago to Denver, Colorado, the typical cruising altitude is approximately 38,000 feet. As the flight departs from O'Hare International Airport, ORD is the airport code for O'Hare because it used to be called Orchard Field, the jet begins to ascend. At 4.3 miles away from the airport, the jet is at an altitude of 4,200 feet. The jet reaches an altitude of 36,700 feet at 167.5 miles from the airport. Determine the slope of the ascent of the flight and round to the nearest hundredth. So we need to first key in on what are my important pieces of information here, because there is extra information. Certainly the fact that O'Hare Airport is Orchard Field is extra information, but there's an extra numerical value. So right now we know 43 miles away from the airport, the jet is at an altitude of 4,200 feet. It's 36,700 feet at 167.5 miles away. So those are going to be my two ordered pairs that I'm going to work with. We're going to go miles first, so we're going to do 4.3, because that's our independent variable. We know how far away from the airport we are. We need to know how high up we are above the ground, and that's going to be 4,200 as our y. And for our second point, we have 167.5, and we have 36,700 as our y. And now we just need to do what we've been doing. We're going to find the slope. 36,700 minus 4,200 over 167.5 minus 4.3. And when I do that subtraction, I get 32,500 over 163.2. And when I do that division, I get 199 point, I'm told to round to the nearest hundredth, 0.14 feet per mile. So what this means is for every mile you go away from the airport, you are going up 199.14 feet on average, right? And we've got a random picture here. This is old school. See if you can find Mr. Boland in this picture. That is the engine of a Boeing 777 or 777, one of the bigger aircraft out there today. And that just gives you an idea of how many high school students can fit inside of one of those engines. And this aircraft has two of those engines on board. Welcome to the year 2001. All right. Now we have Mr. Slope Guy. This is a visual representation to help us remember what slope looks like. So if we're going up, we have a positive slope. If we're going down, we have a negative slope. If it's vertical, it's undefined, giving him a nice little nose. If it's horizontal, we have a zero slope, represented by the dimples of Mr. Slope Guy. So that is our lesson on slope. If you have any questions, make sure you bring them to class tomorrow. Otherwise, I hope you have a great day.